Check, check, check. Is it audible now? Can you just hear me? I just want to know in the live chat. Come on, everybody. Yes, 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 yes. Everyone, everyone. Okay, yes, I believe. It's fine, I guess now, huh? Yeah, that's fine. Okay. And I just want to know, is everybody doing great? Huh? How many of you people are feeling great actually? And I have recently made the two videos. The first one was about the timetable, and the second one was the killer strategy on 99 percentile. Okay, how to get 99 percentile. So I hope you have watched both of those videos. Okay, that's very nice. And I just want to know how many of you are feeling great today in the live chat. Come on, drop a thumbs up, heart, show me something, show some love over there. Okay. Sir, this week's schedule not posted yet on community tab. Okay, we'll try to fix that from the next week onwards. Okay, we are really sorry for that. We'll definitely fix that issue. That's a bug. And we'll keep posting every single time. From tomorrow, me and Love sir are basically thinking we'll just keep posting those stories. Okay, those stories are something different, not the shorts. We'll be basically letting you know every single time which classes are coming up, what we're gonna be doing in what class. Okay, good evening, good evening. Okay, fine. Okay, that's great, that's great. Shall we start, guys? Shall we move? I guess we should start. Yeah, I'm absolutely fine, thank you. Only guy with that is over here. He asked, how are you? Nobody else. Okay. Fine, thank you. I'm absolutely fine. Okay, fine. So this is a piece of information about me. My name is Yawar Manzoor. Okay, and I'm from Kashmir. I'm a JEE Physics expert. This is a piece of information about me. You can just read it out over here. Fine. Now, ladies and gentlemen, apart from this YouTube platform, we have our own Unacademy's platform. Okay, there you can basically take the Plus subscription and Iconic subscription, because you're gonna be basically getting lots and lots of benefits over there if you take this Plus and Iconic, because country's top educators are basically teaching you over there. So definitely I suggest you to join that one. Okay, so what you're gonna get exactly, that is the personal guidance. Fine. This is in the Iconic. Let me basically explain what comes in the Plus. So if you take this Plus subscription, you'll be getting live classes, you'll be getting weekly test structured courses, unlimited access. Means you can watch anybody's lecture any damn time. Hi, what's up, what's going on? Okay, you can watch anybody's lecture any damn time, because country's top educators are for sure teaching you over there. Okay, quota's top educators are over there present. So you can definitely, if you wanna basically boost your rank, you can definitely go for that. The electrostatics, it will be of most probably 10 lectures. Okay, yeah. And in this one, we're gonna be talking about, and in this Iconic subscription, you'll be getting all the benefits you get in Plus, and there are some extra benefits as well that you're gonna get in this Iconic subscription. That's why we call this Iconic, means golden. Okay, and in that you'll be getting the personal guidance, you'll be getting a personal mentor that will help you throughout your exam till you crack the IIT JEE. Okay, and then you have the test analysis you'll be getting in this one, experts guidelines, study material, study planners. Okay, hi, good evening. Fine. So you can definitely follow me on Unacademy. This is my username over there, and you can definitely follow me because we come up with special classes every single day. Today also at 8 o'clock, we have the special classes in which we're going to be talking about some of the beautiful problems. So I suggest you to join me at 8 o'clock. Understand? 8 o'clock. Once we get done with this class, afterwards, we'll move on to the special classes. That's on Unacademy app. Understand? You have to log in over there. That's completely for free. You don't have to pay anything. Just you have to do one thing. You have to use my code over there in special classes. Use this code to unlock my lectures. Understand? Then you can watch any of my lectures over there. You are not only a physics expert, you are a model with a good heart, sir, with tons of. Thank you so much. Means a lot. Thank you. Okay. Okay, next we have, if you take this IIT JEE Iconic subscription, definitely we will send you the branded notes, that too in the hard copy. No need to basically learn from the soft copies or PDFs anymore. So you have to basically take it for 12 months, 18 months and 24 months. Then only we'll be basically sending you. So this is the plus subscription offer. You can definitely, if you grab it for 12 months, if you take it for 12 months, you will be getting 2 months of extension. If you take it for 24 months, you'll be getting 2 months of extension. Fine. Now, you can take this plus subscription that I already explained in the first slide. You can take it for 12 months. You can take it for 18 months. You can take it for 24 months. For taking 18 months, this will be the price, and the prices are basically mentioned over here. Now, if you want the maximum possible discount in this price, understand? So you have to use this code. Use this code in order to get the maximum possible discount for sure from this price also, understand? So use this code in order to get the maximum possible discount. This is my code over here. Now, you can take this Iconic subscription as well for 12 months, for 18 months and for 24 months. By using my code, you can definitely get the maximum possible discount. So you can definitely, from this amount also, you can get the maximum possible discount if you use this code. So I suggest you to use this code only. Use this code only. Fine. Now, we have this beautiful feature on Unacademy, that's Ask a Doubt. Okay, one second. Okay. Actually, I missed the 2 of the slides over here. It's from the back end actually. Fine. So I'll just tell you. So we have this beautiful feature on Unacademy, that's Ask a Doubt. If you have any sort of doubt, you can definitely take a picture, upload it on Unacademy. You will get the solution within no time. Understand? Others are Hindi. I'll tell you English about the English batches also. Okay. Let me just make you understand over here. Arre yaar. Keep. One second. Hold on just a second, man. Now, ladies and gentlemen, let me make you explain over here. We have people keep asking me every single time, sir, there are no batches in English on Unacademy Plus. Ladies and gentlemen, we have recently launched the 2 batches. The first one is called this one. This one is called the Spark batch. And the second one is Shine batch. Okay, Shine batch. You can definitely enroll in both of these batches because country's top educators are teaching you in both of these batches. Understand? So this one, both will be starting first. This one will be starting from 18th onwards. This have already started from 11th onwards. So I suggest you to take any of the subscription from these one, or either you enroll in Spark batch or you enroll in the Shine batch, because teachers, educators will be completely teaching you in English language only. Understand? That's what I suggest you. So by using my code is basically Yawar. My code is basically Yawar. By using my code Yawar, you can get the maximum possible discount in both of these batches also. Okay. Now people keep asking me every single time, there are no batches in English, sir. Definitely we have launched this batch, Spark batch, and this Shine batch. So you can definitely grab this offer right now, right here. Okay. Yeah. Chinmaya. Basically, I'm not sure if this is your correct pronunciation. Okay. So we have launched these batches. You can definitely go for this one. Okay. We have recently launched these batches. So I suggest you to take any of these subscriptions. Okay. Fine. Now let's move on to this one. This is a mega combat. Understand? This is a scholarship test. You can definitely go for this one. You can win the scholarship up to 4 crore plus. Understand? If you get the rank from 1 to 3, you'll be getting 1 year of IIT JEE Plus subscription free. Understand? So you should definitely go for this one. This will be on 22 of August, 11 a.m. 60 minutes, 21 questions. And these are the other benefits that you're gonna get in this one. You should definitely enroll in this one. So if you wanna basically enroll in this one, you can use my code. That is Yawar. That is this Yawar. Use this code in enroll this one also. Understand? This is the Unacademy IIT JEE Mega Combat, 22nd, 11 a.m. Everybody understood? Everybody? Now, let's move on to the next one. This is, if you find any of my content as inappropriate, you can definitely report over there. The link will be in the description below. Okay, everybody. For NEET, any English batch, we'll be launching the English batch for NEET as well very soon. So chill scenes. So ladies and gentlemen, we're going to be talking about the electric field today. What is electric field all about? Can you just tell me in the live chat? Come on, I want you people to show me the same energy that I have. Yawar sir, OP. Okay, fine. Everybody, come on. Can you just tell me what this electric field is all about? Or I just wanna, what is a good book for theory? You can definitely go for, first of all, you should start with the NCERT, okay? Afterwards, you should move on to the H.C. Verma. Once you get done with that, move on to the Singage or D.C. Pandit, to the point, everything, because there will be the categories of problems that is very necessary, okay? Definitely you should go for these. Now, if you want to understand the theory in more detail, go for the Halliday Resnick as well. Completely depends upon you, which book you exactly like. Okay, fine. Come on. Ladies and gentlemen, I just want to know in the live chat what this electric field is all about. Understand? If, for example, there is a charge, there is another charge, they are interacting with each other. Understand? This is applying the force on this one. This is applying the force on this one. See, there is a no contact between these two charges. Then how are they applying the force on each other? Huh? Is there any sort of medium in between these two? Can you just tell me? Come on, everybody. I just want to know in the live chat. Let me just make you understand this concept, that is the electric field concept. Understand? You getting me what I'm trying to say? Now, see, ladies and gentlemen, boys and girls, listen to me very carefully. Listen to me very carefully. Fine. Okay, fine. So, now see, if I say, for example, I have a charge over here. For example, this is a plus Q charge over here that I'm placing over here. Fine. Now, what I am exactly doing, I'm taking this charge. This is the another charge. Okay, this is the another very small charge. I call it the test charge. For just a second, you just we don't know what is this test charge. Just for a second, I'll make you understand this afterwards. So we took this test charge and we bring it over here closer to this charge. Understand? What we actually observed, we have studied this in the last lecture. What we exactly observed, this charge is applying the force on this charge. Understand? This is positive charge. We say this is also positive charge. So it is repelling this charge in the outward direction over here. Fine. Everybody. Fine. Now, can we just say I took this charge from here also? Now, from here, what I exactly did, I took this charge from here and I placed it somewhere around here. I observed that over here also it is basically exerting some force. This is applying the force on this one over here in the outward direction. Fine. Now I took the same charge, I placed it over here. At this point, this is also exerting the force. This is basically applying the force on this one. So I can say, now I took the same charge, I placed it over here. At this point, this is also again, basically, this is applying the force on this one. Again, I took the charge. Here also, this charge is applying the force on this one. Fine. Means around this charge, wherever I am placing this charge, test charge Q, this small q, the force is being exerted on this test charge Q. Can I say that around this charge, in this region, for example, if I say this is the region over here, because this will give you the clear understanding. So, can I say that in this region, this charge is experiencing some sort of force because of this one? Understand? Now, if I take this charge and I place it at infinity, this is not experiencing any sort of force. Hey, understand? You might have observed this in your real life also. If I am placing the magnet over here, this is a magnet, okay? Now, at this point, I'm placing a piece of iron. What will happen? It will attract it towards itself. Understand? Now, I'm placing the piece of iron over here. It will also attract. Now, I'm placing it over here. It will also attract. So, can I say around this magnet, there is some sort of field? That's what we call for instance, you call that magnetic field, just in order to make you understand. So, around this magnet, if we place this piece of iron, this is being attracted. So basically, this is creating some sort of field around it, in which if this piece of iron comes, it is being attracted. It is being attracted. Everybody understanding? Drop a thumbs up. Yes. Thank you. You have to show the love from your side, okay? You need to understand this. That's why I'm showing lots and lots of energy. And we are running this Fury series. We have to be very energetic. That's why. Okay. So can I say that by using the same concept, by using the same logic over here, I can definitely say that, see, around this charge also, there is some sort of field. Understand? Some sort of field is being created over here. Whenever this test charge Q is coming in that field, inside that field, it experiences some force. Understand? It experiences force. Now, can you tell me, first of all, what is being created? When the two charges come close to each other, is a force being created in the initial step or field is being created? First, field comes into play. Afterwards, force comes into play. Understand? Afterwards, they start interacting with each other. So we got the answer of that question. What question? We said previously, if this is a charge, they are interacting with each other. This is applying the force on this charge and this is applying the force on this charge. So they are interacting with each other. If there is no contact between these two charges, then how are they supposed to interact with each other? This is illogical. This is an illogical, I would say, illogical point. Understand, everybody? So from now onwards, we can say there is some sort of medium. That medium is what we call the electric field. Because of that electric field only, this force is being created on this charge. This force is being created on this charge. Now, everybody understood this concept of field. Drop a thumbs up, drop a heart, whatever you want to send in the live chat. Come on, everybody of you. This is an English badge, okay? Okay, that's why I'm having lots and lots of energy. Because there are no English teachers. Actually, we should show, or we should have this much of energy when we teach you people in English language only. Because you might have seen the teachers teaching you in Hindi having lots and lots of energy. That's why I'm trying to give you the same feel over here in this English batch also. Understand? Now tell me, what is being created first? Electric field or electric force? Electric field or electric force? How electric force comes into play? Is it because of electric charge? Definitely yes, it is because of electric charge. Okay, that's nice, Praveen. Fine, everybody understood this one. I hope everybody got the feel of this one. So we can say from now onwards, this electric field is nothing. It's a region. It's a space around a charge in which if any test charge comes, it experiences force. Now you say, sir, what is this test charge? This test charge is which is having very small magnitude. You can understand it like that, which is basically positive in nature. We take this test charge as positive in nature. Understand? You getting me what I'm trying to say? Now you will ask, sir, every charge in this world creates field around it. Understand? Previously we studied this charge. If this is a charge, this is a charge. They both are interacting with each other. This is applying the force on this one. This is applying the force on this one. Means that this is also creating the field. This is also creating the field. Now the point over here is, will this test charge also create the field? No. This will have zero field. Understand? This test charge will definitely have zero field. Why? Because we use this test charge for the testing purpose only. This is just test story. Okay. Fine. Otherwise, we say in real life, every charge creates the field around it. Now we assume that this test charge creates zero field because we use it for the testing purposes only. Understand? In reality, there is nothing like that. Fine. Just you have to understand this. You have to agree with this. This is what are the laws of physics, and we have to understand, we have to basically go with this only. Everybody understood this one? Everybody understood this one? Drop a thumbs up. Now the point over here is, sir, you said what is this electric field? This electric field is a space around a charge in which its influence can be felt by any other charged particle. Means that this electric field is a region around a space. If any test charge comes in that space, it experiences the force. Understand? Like I told you, this is the charge over here. For example, if I say this is a region around this space, this is the region around this test charge in which if any test charge comes, it experiences the force. For example, I say over here it's outward. I'll tell you what is the direction over here after some time. Everybody understood this one? I hope this is clear to everybody. Okay, that's nice. It's gonna be you. And before that, I want everybody of you to like this session as soon as possible, okay? Come on. That's nice. Okay, okay. So, shall we move? Fine. Now, how to find the direction of this electric field? What is the direction of this electric field? What is that method by which we can find the direction of electric field? Previously, it was easy to find the direction of force. This was charge, this was charge. This was applying the force on this charge in this direction if both were positive. This was applying the force on this charge in this direction if both were positive. Okay, fine. Now the point over here is how to find the direction of this electric field. It's a very simple method, okay? Now see, if you take this charge over here, understand this is a positive charge plus Q, okay? Now you do one thing, you take a test charge nearer to it, understand, in its field. If I say this Q, if you observe that this test charge Q is always positive in nature, keep that thing in your mind, this is always positive in nature. If you analyze that this test charge is being pulled or pushed in the outward direction, in that case, you say that the electric field is in the outward direction. Electric field is in the outward direction. Fine. If we say this is a charge Q, we have to find what kind of electric field this is producing basically. You take a test charge, you take it nearer to this charge in its field. If I say field is around it, if you experience that this charge is being pushed in the outward direction, force is acting on this charge in the outward direction. So we can basically say in that case, the electric field is in the outward direction. That's why it's pushing this charge, same charge, repelling this charge in the outward direction. Everybody understood this one? Drop a thumbs up. Come on. Okay. It's gonna be okay. Fine. Now, if we have, for example, over here, if we have a negative charge over here. Now, if we take any, arey yaar. Now, if we have a negative charge over here, I'll just rub it. I can make it over here. I'll just rub it. This is negative charge over here. I'm basically placing the negative charge over here. If I say, for example, there is a field around it. For example, it is like this, okay? Now, if I am taking the test charge Q that is in its field over here, what I'll observe exactly, this will be pulled in the inward direction towards the charge. In that case, I would say electric field is inward. Understand? Or we say towards the charge. It is towards the charge. Everybody, in this case, electric field is away from the charge. So from now onwards, we can say the charge, positive charge basically show the electric field that's away from the charge only, and negative charge show the electric field that's towards the charge. Okay, everybody understood this one? Everybody understood this one? Let's move on to the next one. Let's move on to the next one. Everybody drop a thumbs up. I just need to know in the live chat right now how many of you people are understanding this lecture. Come on. I want everybody of you to send me the thumbs up. Come on, everybody. Yes, yes, yes. That's very nice. That's very nice. So from now onwards, what will you understand? What is this electric field? It is some sort of field. It's some sort of region around any charge in which if any other charge comes, it will experience force. It's a region. It's a field basically. Understand? Like we have gravitational field over there. Same is the case over here. Magnet, it is creating the field around it. And if in that field any, for example, a piece of iron comes, it will get attracted. Force will be basically on that electric field. Force will be on that piece of iron applied. Okay. Now, what is this electric field strength? If I asked you previously, see, this is a charge Q. This is a charge Q. They are interacting with each other. This is pushing this in the outward direction, means this is applying the force on this one. This charge is applying the force on this one, pushing this charge in the outward direction, means you say, okay, there is force. Then we basically asked, how much is this force? 10 Newton, 20 Newton, 30 Newton. Same is the case over here. If we have the electric field over here, if we have the electric field over here, if we have the charge over here, this is a charge over here. it will have a region around it. That's what we call the electric field. I say how much amount of electric field is it producing? What is the magnitude? How much stronger it is? How much strong electric field it is basically creating? More strong electric field it will create around it, more force it will create on that test charge. If I say around it, the electric field is very, very, very strong. Now, if I take any test charge in that field, what's gonna happen? It will push it in a, understand? So completely we can say, more strong the electric field, more will be the electric force. Everybody is understanding this one, man. Everybody is understanding this one. Is this lagging? I need to check my Wi-Fi settings. Yeah, it's connected to 5G only. Okay, fine. See, it's like basically I'm placing the bigger magnet with a nice material, okay? Made of nice material. I'm placing that magnet over here. Piece of iron I'm taking close to it. It's attracting it very fastly. Why? Because there is a strong field around it. Understand? Now, if I'm taking the smaller magnet over here, in that case, the field around it will be very small. So it will be attracted with a less force. That's what I'm trying to say. How much is the electric field strength or intensity? How much is the electric field intensity? How much is the electric field strength? That's what I'm talking about over here. How can we exactly find that? Now, there is a simple method how to find the electric field intensity of any charge. Understand? How do we exactly find that? Let me just show you. See, you do one thing. You take that charge. This is a charge. You want to find how much is the electric field intensity of this charge. What you are supposed to do is that you take any test charge, you bring it nearer to this one, you place it in this test charge, you place it in the field of this charge Q. You are basically taking this test charge and placing it in the field of this charge Q. Understand? Now, you will check how much amount of force is being applied on this charge because of this one. You'll check how much amount of force is being applied on this charge because of this one. So, electric field intensity, we write, that is force on test charge. Force on test charge. How much force is being applied on this one? It is very simple. As I told you, the more force on this test charge will be, the stronger will be electric field. Lesser the force on this charge, less will be the electric field. Simple. So F test over here, and you will put the magnitude of test charge over here in the denominator. That's all. This is the method how we find the electric field intensity. That's all. Understand? I hope you got the feel. How much is basically this one? So can I write over here? It is nothing but F by this Q, because this is the magnitude of this one. How much is this charge? F is force acting on this one. Charge is how much is this charge exactly? So can I say how much force is that? Previously we have studied from the Coulomb's law. That is Q upon R square. That is R is the distance between these two. Understand? If this is at R distance from this one. So can I say this is nothing but Q, this Q upon this R square, and this will be Q over here. Can we say this will get cancel off? It will be nothing but Q upon this R square. So can I write this electric field as that is nothing but Q upon this R square? So this is the electric field intensity of this charge Q. This is the electric field intensity of this charge Q. Everybody understood this one? Drop a thumbs up. You got the feel? Come on, everybody. I just want to know in the live chat, man. Okay. Everybody understood this one? I hope you're getting the feel of this. Okay, fine. Let's move. So this is basically the electric field intensity. This is basically the electric field strength. Fine. Now, okay, let's have a look on this electric field equation over here. Can we say that the more the magnitude of this charge, more the magnitude of this charge, more will be its electric field over here? And previously, like, more the magnitude of charge, more will be the force created by that Coulomb's force. Same is the case over here. More the magnitude of this charge, more will be the electric field intensity from the question itself. Now, over here we can say E is inversely proportional to R square. This was in the Coulomb's law as well. Understand? What is this? E is inversely proportional to R square. It means, for example, see what is this R? If this is a plus Q, and at this point we are placing the test charge. So this is at, for example, R distance, this test charge, okay? Now, at this point, if I ask you how much is the electric field intensity, you will say how much stronger is electric field at this point. That is what electric field intensity at this point exactly means. Okay, so we say E is equal to Q upon R square, that I proved. Okay, fine, at this point. Okay, now if I ask you, if we increase this R, what's gonna happen with the electric field intensity? It is common, yaar. In case of the force, we said it is decreased. Same is the case over here. The more we move away from the charge, the electric field will decrease. It's simple, yaar. If we place a magnet over here, okay, this is a magnet, this is a piece of magnet. Tumhe jo maine dekha. I'll just show you over here. If we place a magnet over here, okay, now at this point, I'm placing the piece of iron. It will get attracted to this, towards this magnet with a greater force. Now, if I increase this, this radius, this was R. Now, if I place it at R2 distance, okay, R2 distance, that's larger than this one. What's gonna happen? It will now get attracted towards this with a lesser force because we increase this R. You can compare it with that one, nah. So that is the same case over there as well. If you increase this R, that electric field will decrease. Now the point over is how many times it will exactly decrease, how many times, that we are supposed to talk about over here. E is inversely proportional to R square. If R is increasing, E is decreasing. If R is decreasing, E is increasing. Means if you go nearer to this charge, electric field will increase. I hope everybody is getting the feel of this one. Now see, listen to me very carefully. If I say, for example, see, E is inversely proportional to R. So meaning of this is also same. If we increase the R, electric field will decrease. But this has the different meaning, bit different meaning than this one. What does this mean exactly? Now see, if I say, for example, at this point, how much is the electric field? If I say R is equal to 1, how much is electric field? You will say E is proportional to 1 by R square. So you will say 1 by, that is 1, electric field will be 1. So means at this point, electric field will be nothing, but I call that E. Fine. Now, if I double this distance, so I would say this is plus Q. I'm doubling this distance. So right now, R is basically 2. If I ask you how much is the electric field at this point, you will simply say electric field at this point is nothing but E is equal to 1 by R square. It will be nothing but 1 by 2 square. It will be 1 by 4. So 1 is what? Electric field. So this is new electric field at this point. See, at this point, electric field will be different than this point. So I call this as E dash. So E dash will be nothing but, can I say it will be nothing but E by 4. Means electric field has reduced by 4 times. If you double the radius, electric field will be decreased by 4 times. That's what it exactly means. You have question in your mind. I know you have question in your mind. Sir, why don't we take this one? Why do we take this one? The reason for that is basically, experimentally, it has been proved that when we double the radius, electric field is decreased by 4 times. Understand? It is not linearly decreasing. That's why we are not taking this one. We take this one. I'm fine, man. Okay. Come on. Everybody understood this one? Everybody understood this one? Okay. Now, if I say, for example, over here, let me just show you in this one. If I say, for example, electric field is basically, I'll show you like this. I'll show you like this. Meaning of this one also, meaning of this one also. If I say this is a charge Q at this point, electric field is E. Now, if I reduce this R, where R is 1, if I reduce this R, if I make it half, at this point, if I say R is 1 by 2, at this point, how much will be the electric field? You will say E is, 1 second. I hope everybody is understanding this one, because this I have already explained in the last lecture. That's why I'm going. I'm not a boy. It's okay. Okay, girl. Sorry. Okay, E is equal to 1 by R square. That is nothing but 1 by 2 square, because we have reduced this. We have made this half. So can we say it will be nothing but 1 by 4? It will be nothing but 4. 4 of E. This is new electric field. So if we basically decrease, make the electric field as half, if we make the radius as half, the electric field will be increased by 4 times. That's why we take E is inversely proportional to R square, not E is inversely proportional to R. I hope this you have understood. And if we check from the graphical point of view also, the graph is coming out to be basically like this also. So E is inversely proportional to R square. Understand? We experimentally checked that the graph of electric field versus R is coming out to be like this. That is, the equation of this line, the equation of this curve is inversely proportional to R square. Oh, hey. I need some water, man. Everybody, take a screenshot of this one because this won't come in your notes. That's why I'm saying. Take a screenshot. Okay, fine. It's gonna be okay. अब क्या ये वाला? Now. Yawar sir is best. Thank you, sir. I know who is writing this. Okay. Thank you. Thank you. Means a lot. This dill is for you only. Okay, okay. Okay, okay. I want everybody of you hit like for love, sir. Send a heart for love, sir, right now. Okay, everybody. For love, sir, not for me. For love, sir, everybody. Yes. Yes, it is same as Coulomb's law that we discussed in the last lecture. Yes, exactly. Okay, fine. Okay, let's move on to this one now. Let's talk about the electric field due to a positive point charge. Understand? How much will be the electric field due to a positive point charge? Till now we were discussing this only. See, if I say this is the positive charge over here, this is a point charge, positive point charge over here. At this point P, how much is the electric field? It has to be like this. It has to be like this. Understand? So electric field will be away from the charge that we have discussed previously. Understand? Because if we take a test charge nearer to this one in the field of this plus Q charge, we will observe that that's being pushed in the outward direction. So we can say in that case, the field is in the outward direction. It will be something like this. So I'll make it, this is a plus Q. So around it, the field will be something like this. This is just an example that I'm giving you so that you can get the feel of this one. This is outward. You can show it like this, outward electric field. Understand? Outward electric field. Why? Because we have tested this previously. Okay. We took the test charge nearer to this one, nearer to this charge in the field of this charge, and we observed that that's being pushed in the outward direction. That's why at this point P, I'm showing it in the outward direction. That's why I'm showing it in the outward direction. Now, if I ask you how much is the electric field over here, we will simply say E is nothing but that is K, Q, this Q. I'll just write it. This Q upon how much is the distance between this point and this point? That is R square. What is the direction? And that will be away from the charge. Away from the charge. Fine. Now, let's talk about this one. This is a negative charge over here. If we talk about the negative charge, if we take any test charge nearer to this charge in the field of this negative charge, what's going to happen to that? It will be basically attracted. It will get attracted to this negative charge. I want everybody of you to join this Telegram channel that you can see in the live chat right now. JEE English Unacademy. This is the official Telegram channel of JEE English Unacademy. From now onwards, I'll be putting up my notes in that channel only. So I want you people to hit the subscribe button, whatever it is. Join that very soon. Okay, everybody of you. Fine. Now, can we say that at this point P, electric field will be towards the charge? Why? Because if we place a point charge over here, that will be attracted towards this charge only. Because point charge, we always take what? Positive. And one more thing. See, we say electric field is zero at what? We say electric field is zero at infinity. Understand? Keep that thing in your mind. When you go away from the electric field, it keeps on decreasing till you reach infinity. It becomes zero. Fine. Now, ladies and gentlemen, I just want to tell you. Okay, now have a look over here. Can we say in this case, electric field will be nothing but K, that Q upon R square, what it will be towards the charge, towards the charge. Exactly, fine. Now if I try to make it over here, I'll just show it. This is the plus Q, and if I show this is the region around this charge, and the electric field will be something like this towards the charge, So we can definitely show it like this. Let's move on to the next one. Okay, fine. Now see, listen to me very carefully. See, if I say point charge in an electric field, what does it mean? Previously, we were talking about the test charge. We were playing with the test charge. Now we will be seeing what's going to happen to the point charge if we place it in the electric field. So this is basically some sort of, you can understand it like this. This is a constant electric field, or this electric field is the parallel electric field created by any machine. Understand? Previously, we were talking about this is a charge. Around it is being basically produced. The electric field is around it because of this charge. If we take any charge closer to it, one in its electric field, it is being pushed, or that whatever it was. Okay. Yes, for now, I'll tell you. Yes, for now. See, every time, whenever I say, instead of that sign, negative, positive, if I say, we just simply write towards that, then that will give us the complete direction. Yeah. Away from the charge, towards the charge. That will give us the clear indication what is the direction of that electric field, force. Fine. Now, see over here. So this is the electric field that's created by some charges, that's created by some machine, whatever it is. So this is the electric field over here. This is the region of electric field, I can say. Now we took a point charge, not the test charge, a point charge, and we placed it in this electric field. This you have to study in the upcoming time in very detail. For now, I'll just tell you a bit of a concept, okay? We don't go in detail. We don't have to learn this in detail for now. Just, okay, so if we place this point charge in this electric field, what's gonna happen? So basically force will be basically applied on this test charge, because on this point charge, because of this electric field, and that force will be towards the electric field. It will basically move along the line, along this electric field only. Understand, that force will be towards this electric field only. If I ask you how much is the magnitude of that force, you will simply say F by Q, and F is nothing but Q times of that E. How much is this electric field over here? Q times E. So clearly we can say over here, this is the force on that charge Q. Simple concept, understand? And keep that thing in your mind. It will be along the electric field, Let's move on to the next one. If we place the negative charge, if we place the negative point charge in the same electric field, what's going to happen? Force will be applied on this charge. So how can we find that? That's FQ will be nothing but same Q times of E. Understand? Now if I ask you what is the direction of this force, it will be opposite to the electric field. You will say why opposite to the electric field? See, you can imagine it like this. The electric field is coming from some sort of source over there. Understand? And this is a negative charge. If that electric field is creating like this is a negative charge. This will obviously get attracted towards that. You can understand it like that also. Fine. Let's move on to the next one. Vector form of electric field. Same method that we used in previously. Everybody. Same method that we used in previously. Okay, let's have a look on this one. Now this is a charge, and I'm placing the test charge in its region or nearer to this one. So what's gonna happen? At this point there will be some electric field. If I say how much is the electric field, you will simply say, sir, electric field is nothing but K. How much is the magnitude of this charge? That's Q upon what is the distance between this point and this point? That's R square. So this will be the magnitude of electric field. This will be the strength of electric field at this point. Everybody? Yes. So at this point, this will be the strength of electric field. Now, if I ask you to tell me the vector form of this one, what is vector form? Whenever we talk about the vector form of any quantity, means we have to represent its magnitude, how much it is, how much amount, okay? And we have to show it we have to show its direction as well. In which direction this quantity is basically moving, we can say it like that. So this is how we represent the vector form. So right now we know the intensity of this electric field at this point, understand? And that's how much, that's kq by r square at this point, we know. Now the point is, at this point, how to find the direction. See, it is away from this charge, that we know. But how to find mathematically the direction of this electric field at this point, that's away from this one. That's we will use the vector method that I have showed you previously when we were talking about the forces, Coulomb's force and all. I hope you remember everything of that class. Now see, if I say, I'll show you 2-3 methods. Don't worry about that. The first method is basically, now see, if you travel from this point to this point, you can show it like this is a radius. From this point to this point is a radius vector. You can call it radius vector, understand? So we can basically show it like this also. Fine. Now, if I ask you how to find the direction of this electric field, if you have to find the direction of any electric field, any quantity, you have to take a unit vector which is along the direction of that quantity. Understand? Now here, which unit vector we can take exactly? Why do we take unit vectors? You might have studied this in our vectors, huh? We take unit vectors for the direction purpose only, na? That's why. So we'll take the unit vector of this r, because this r is also along the direction of this electric field. We are taking this r only. Understand? So we're taking this r only. If I say we'll take the unit vector of this r, that is this unit vector will have the same direction as this electric field. Understand? So if we place this unit vector over here, this will definitely give us the direction of the electric field. If you want to find the direction of any quantity, just place the unit vector over here, which is along the direction of that quantity over here. Along the direction of that quantity is this r. So we can take the unit vector of this r, because unit vector we use for direction purposes. This unit vector is having same direction as this one. This is having same direction as this one. So we can say this is having same direction as this one. Okay. So can we basically say it will be nothing but r unit vector over here. Magnitude of this is 1 unit vector. So we know if we have a unit vector a, we can represent it like this. That is the vector a upon magnitude of vector a. So for this r unit vector, we can definitely write it like this. This will be kq upon this r square. And instead of this unit vector, we can write r vector by magnitude of r vector. Understand? So it's the magnitude, this is a magnitude, this will get multiplied to this one. E is nothing but kq upon r square, r into this r, it will be r cube and this r vector. In some books you can find it like this. I'll show you the other methods also, don't worry about that. Fine. Let's go for the next one. If we say, for example, this is a charge q. At this point, we are supposed to find the point P. Don't mention the point P, you'll get confused. At this point, we are supposed to electric field. We say it is away from this one. This is electric field away from this one. This is the radius r from this point to this point. Now, how much is the electric field intensity? How much is the electric field strength? You will simply say that is, sir, q, k, this q upon r square. Distance between these two at this point. Fine. This is the magnitude. Now we have to find the direction as well. Now, if you move from this point to this point, can I say that at this point, the position vector r1, r is r1, I can call it like that, or simply r over here, it is r dash means r, or simply r2 means r1, whatever it is, or simply you can keep it like over here, nothing but this is, for example, r0, over here it is r. Okay, so when you traveled from this point to this point, how much a distance you have traveled and in what direction? This direction. If I say how much is the unit vector, how much is the vector, this radius vector you have traveled, you will say simply, or the displacement, how much is the displacement you have traveled? You will say simply, this r is nothing but, that is the displacement from this point to this point. That is r minus r0 when you are traveling from this point to this point. Fine. So what is the direction of this one? This is having the same direction as this electric field outwards, because you are traveling, this is the displacement, you are traveling in this direction. And this is the point, this is the point. You are traveling from this point to this point. Over here, I say this is r1. Over here, this is r2. r2 minus r1. So direction is what? Towards the right. Fine. Now, if I tell you right now, so I can represent this r as this r minus r dash. Now, this r minus r dash is having r minus r naught. This r minus r naught is in the same direction as this electric field. Now, if we want to find okay, there are so many books that I refer before preparing for any of the lectures. Okay, yeah, exactly. Some coaching materials, some books, some websites. Okay, now see. So E is equal to KQ by R square. Understand? Now you will say from this point to this point. So this is the unit vector. This is the radius vector. Understand? Along this this electric field E. Now if I ask you how to find the direction, you will simply say we'll take the unit vector. Unit vector of what? Unit vector of this R, because this unit vector of this R is having the same direction of this E, that is along this one only. So that is, what is this R? That is R. This we can definitely write it. This is R minus R naught. It's unit vector exactly. Fine. Now, can we say it like this? It is KQ upon, instead of this R, I can definitely write this one, because this R is only that one. Now, from this point to this point, if you move, then it will have that direction. Now, so can I say instead of this, I'll write this R minus this R naught, its square exactly. And because of, instead of this unit vector, we know A unit vector is nothing but A vector upon A mod of A. Yeah, everybody is understanding this one. Drop a thumbs up in the live chat. I'll explain this once again. If not, if there is any confusion in your mind, I need to know right now. Okay. So can I basically put it over here? Instead of this, I'll definitely write it. So unit vector is equal to A vector upon mod of A. So I can definitely write this will be R minus R naught, this vector, upon mod of R minus R naught, its mod. So finally, I can basically write this is a vector, this is a vector. It will be nothing but KQ upon, this will be this magnitude multiplied by this magnitude. It will be nothing but R minus R naught, its cube. And it will be nothing but R minus R naught, its vector. So this is the another way of writing this vector form. This is the another way of writing this. I was very excited for today's class, but there is network problem in my home, sir. It's okay. You can watch the recorded one afterwards. Not a problem. Okay, fine. This was the vector form. We got done with that. Okay, it's gonna be okay. Okay, there is no water in my bottle. I need to go out to get some water. Okay. Fine. Now let's move. Afterwards, I'll get the water. No. Chill scenes. I'll just tell you now, electric field intensity due to a group of charges. Understand? This is like the superposition principle in electric fields. Previously, we were discussing that at this point, if there is a charge, if there is another charge Q1, Q2, there is another charge Q3. Now, if this is also a charge, we were discussing that how much is the net force on this charge. You said, sir, the net force on this charge is the net force due to this plus force due to this plus force due to this. Understand? Net force, that was in the superposition. F1, vector sum of all the individual forces, plus F3 till Fn. Understand? Same is the case over here. Same is the case over here. Let me just make you understand. Let me just give you the feel. Now see, if I say, for example, this is a charge over here. I'll just show you over here. If I say this is a charge over here, for example, this is Q1 plus Q1. This is charge over here plus Q2. This is charge over here minus Q3. This is charge over here minus Q4. This is charge over here plus Q5. Okay. Now, these all charges will create the electric field around it, because every charge in this universe creates the electric field. So they will all have electric field somewhere around here. This will have electric field over here. This will create the electric field over here. This will create the electric field. This will create the electric field. All of these charges will create electric field. Now, yes, I'll show you the problems also. And if you wanna go for the next level problems today, then I suggest you to come to my special classes. Special classes, okay? That will be at 8 o'clock exactly. 8 o'clock exactly. We'll be talking about the problems from this portion also. Okay? Okay, fine, fine. Let me just finish the concepts, bro, so that afterwards we'll be able to solve the problems only. Directly moving on to the problems, it will create a problem. Okay. Now, now see. Now these are all the charges which will basically create the electric field over here. If I say, for example, at this point, can you tell me at this point, wanna come at this point, can you tell me how much is the electric field due to all these charges? See, if there was only one charge, for example, this Q, if I ask you how much is the electric field over here, you will say, sir, what is the distance between these two? For example, this is R. At this point P, the electric field is, if I say bring a test charge over here, if this is a positive charge, so it will be away from this one. So you will simply say, so electric field at this one will be, sir, that is this Q, this K and this Q2 upon the distance between these two, that is R square. Fine. This is because of this charge. Now the point over here is, I'm asking you to tell me the electric field intensity at this point due to all of these charges. Okay, due to all of these charges. Now listen to me very carefully. So due to all of these charges, we have to find the electric field over here. Now, if I say because of this charge, the electric field will be away from this one, can I say that will be nothing but E2? This is a charge Q2. So because of this charge, it will be nothing but E1. Understand? Now, because of this charge, I'll just shift it over here. Okay, so that I can draw the vector over here properly. So because of this charge, it will be nothing but away from the charge, because electric field is always away from the charge if we talk about the positive charges. Understand? These were the positive. This is the negative charge. Okay. So then it will be towards the charge. So I can definitely represent it basically like this only. Now, this E5 will create the electric field. It will be something like this. This will be E5. Understand? And this was what? This was E4, E1, E2, E3. Where is E3? This is E3. It will be something around, somewhere around over here. Okay. So that will be E3 also. Everybody understood this one? Now, where are you from, being artist? Sir, can I meet you if I come to Kunzar? Where are you from? Now listen to me. Now if I ask you to tell me the electric field, net electric field at this point, you will simply say the net electric field over here is nothing but, net electric field at this point is nothing but, that is electric. We can use the superposition principle. Previously we have basically discussed that. So electric field at this point will be because of this one, because of this one, because of this one, because of this one, because of this one. Simply, that is vector sum of all the individual electric fields. So can I say that is E1 plus E2 plus E3 plus E4 plus E5. Okay, it will go till En if there are n charges over here. Now you will say, sir, this is a negative charge towards, see, I'm writing the vector. In vector, you have to, it will be magnitude and direction will be included in that one only. Okay, so this is basically the superposition principle in case of these charges only. I hope you understood this one. Fine, everybody, come on, let's move on to the next one now. Now I'll be showing you, I'll be asking you the questions. These are the graphical questions. You have to answer me. Rest of the questions which come from the electric field, we'll be talking about the in special classes. Okay, so you can find the good level questions. I'll tell you from which book. The good level questions you can take on these graphs. These may come. This is from the competition point of view. These are very important. Okay, I want you people to focus on these one. So you can find the questions on these graphics, these graphs in the BM Sharma Singage book. Okay, that's a very nice book. I suggest you to do that. Okay, come on, everybody. So if I say, for example, there is a positive charge over here. This is a positive charge over here. What will be its E versus R graph? E versus R graph. Understand? Previously, I told you. I have explained this previously. Kidhar gaya? E is inversely proportional to R. I guess that was in that slide. Okay, blank slide. That's why I'm not able to find that. Now see, we say simply E is inversely proportional to R square. The graph is something like this. Understand? Then R is infinity, E is 0. Understand? What is that? When you go very, very, very far from the electric charge, the electric field basically decreases when you go away from the electric field. With by how much amount that I told you previously. If you increase the radius by twice, electric field will increase by 4 times. If you decrease the radius by make it half, the electric field will be increased by 4 times. Understand? Yeah. Exactly. Now see, so in that case, this will be in that case, electric field will be 0 at infinity. Understand? Now if I say what is the electric field at exactly the charge, that's not defined. Okay. If you put in that equation also, that'll be 1 by 0 square. It's not defined. Okay. So that's why electric field exactly at the charge. R0 means electric field exactly at that point. We take this R away from the charge. R0 means at this point only. That's not defined. Let me just ask you the questions from this one itself. Come on. So can I say in this case, electric field will be nothing but it will be something like this. 100% it will be something like this. Now you say, sir, if we draw properly the proper diagram of this one, if we draw the proper diagram of this one, okay, if we draw the proper diagram of this one, now see, so can we basically say the electric field will be away from this charge and electric field will be away from this charge because this is a positive charge, away from this charge, away from this charge. So in that case, I suggest you to take this electric field which is along the negative direction, negative x direction. You take this as negative and you take this as positive. Understand? In the right side, you take it as positive. In the left side, you take it as negative. Now, I ask you in this question that how am I supposed to draw E versus R graph? We know E is inversely proportional to R square. The graph is coming out to be like this. Now, if the electric field is positive in the right side, you make it like this. From now onwards, the questions will be asked like this only. So, the graph of this, the equation for this is E is inversely proportional to R square. If R is infinity, E will be 0. Understand? At R is infinity, E will be 0. Now, in the left side, if electric field is negative, from which side electric field is negative? Downside. See, in upper side, you can see the electric field is positive. Here, electric field is negative. And in this side, can we basically draw it from this one? In the left side, in negative axis. So, this is in the positive X, this is in the negative X. In the positive X, electric field is positive. In the positive R or X, electric field is positive. We can draw the graph in this quadrant. Over here, we can draw it in this quadrant. Now, I want you people to tell me how we are supposed to draw the graph in this quadrant. Understand? Come on. This is for the negative charge. This is for the negative charge. Can we say it will be towards this? Can we say it will be electric field will be towards this? Can we say? Can I say that? Can I, everybody? Okay. I just want you people to answer this question. Everybody. Come on. I want you people. So can I say that in this case, electric field, this is taken as positive? Why? Because this is along the positive X direction. And this electric field is taken as, this electric field is basically negative because this is along the negative X direction. Now, on the right side of the charge, on the right side of the charge, on the positive X, in the positive X, yes, in the positive X, can we say that this electric field is negative in the positive X? So it will be something around like this. Understand? E is inversely proportional to R square. Why? Because electric field is negative. Electric field is negative. Understand? When R is positive, in case of positive R, electric field is coming out to be the negative in case of negative charge. And in case of, everybody is able to understand. Come on, drop a thumbs up in the live chat. And electric field when positive, that's in this negative R. In this negative R, electric field is basically positive. So can it we basically make it like this? Definitely. E is, understand, positive electric field in negative R. Positive electric field in negative R. Now I want you people to solve this question from your end only. Okay, we have two positive charges. We have this positive charge over here and we have this positive charge over here. I want you to draw this question as well. Okay. Now, so I'll give you the options. This is the option number 1, option number B, This is electric field versus R, electric field versus R. Arey yaar, it will be option number C will be something like this. This is electric field versus R. Being artist, I want you to solve this right now. And D will be something like this. Okay. Come on. Everybody. A, B, C, D. Which option is correct over here? Can you draw the graph over here? A. Come on, everybody. I'm waiting for your answers. I'm waiting for exactly your answers. I want everybody of you to solve this at your own. This is not that difficult. Understand? This is not that difficult. Come on. And like this session. Everybody like this session before you leave. Everybody done? Option B. Option B. Let's see what's gonna come over here. See, first of all, what you are supposed to do is draw this diagram. Understand? Without this diagram, it is impossible to draw the graph of this one. Now, see how exactly you are supposed to do this one. Now, see. We say, what is the electric field in case of positive charge? It is always away from this charge. So we say electric field is positive in this case. See, if it is in the right direction, if it is along the positive x-axis, we say electric field is positive. In this case, we say electric field is over here, it is negative. It's away from the charge. In this case, it is electric field is basically positive. In this case, electric field is basically negative. Okay, we take this electric field as positive, which is along x-axis. We take this electric field as negative, which is along negative x-axis. Okay. Yes, exactly. Being artist, that's very nice. What is that null point? I just want to know from you only. Come on. That can be this one, huh? What is that null point? Means electric field is 0 over there. Can I say it like that? Yeah, manta yaar, catch kara. Okay, now have a look on this one. Everybody, see, this is electric field, this is R. Let's have a look on this charge first. If I say, for example, I have placed this charge Q over here. On the right side, electric field is basically positive. Understand? If electric field is positive on the right side, that is in the plus R. So can I say that it will be something like this? E is proportional to R square 100%. Now move on to the left side of this charge. That is in the negative R. That's in the negative R. Can I say electric field is negative in case of that one? Let me just rub this. Electric field is negative in case of R. See, from the upper side, electric field is positive. From the downside, electric field is negative. I can definitely basically show it like this. It will be something like this. So it will be something like this. Exactly. Fine. Everybody. Now let's move on to this charge. Now this is a positive charge. On the right side of the positive charge, electric field is positive. Means it will be something like this will be exactly the null point over here, where they'll meet exactly. At this point, electric field is 0. And if we move to the negative side of this one, can we say electric field on the right side, on the negative R, it is negative. So it will be nothing but it is like this only. Now, which option is exactly correct? Is this option, this option, this option, this option? Option B, I can see clearly correct. Yes. Everybody, all of you understood? You have to come to the special classes at 8 o'clock. Okay, use my code Yawar over there. On this one, we'll be talking about these questions. Okay, these graphical questions. Come to the special class, we'll discuss some of the beautiful problems. And I have showed so many beautiful problems previously on this electrostatics as well. That is available on special classes, so you can definitely check that out. Come on. Very nice. Come on, everybody of you. What's your name, being artist? Are you the same guy who was yesterday present in my that casual conversation session? Okay, everybody, listen to me. I want everybody of you to make a graph for this one. This is the two negative charges over here. Okay, two negative charges. So this is basically the negative charge over here. So this will be the negative charge over here. Understand? Now, if I say negative charge, in case of negative charge, the electric field will be towards the charge. Electric field will be towards the charge. Electric field will be towards the charge. So we take this electric field as negative. We take this electric field as positive. This electric field as negative. We take this electric field as positive. Okay. Yeah. Okay. That's nice. So if I give you the options over here, it will be something like this. Option B, same. Option C, it will be something like this. Option D, same options. Which option is basically correct over here? Come on, electric field versus R. Okay, Javed. Okay, that's nice. Which class you are in exactly? Okay, Khushi, come on. C. Let's have a look. So electric field is negative. If this is a positive negative charge, I'm placing it over here. Negative charge, I'm placing it over here. Electric field will be basically negative from the right side. So if the electric field is negative from the right side, so I can definitely show it like this. Electric field is positive from the, sorry, this is from the right side. Yeah, electric field is positive from the left side. So if we show electric field positive from the left side, so can we basically show it like this? Exactly. Fine. I can definitely. Okay. Now, let's talk about this charge. In this case, electric field is negative. Electric field is the negative from the right side. If electric field is negative from right side, so it will be something like this. Yeah, exactly. Over here, electric field will be 0. Electric field is positive from this one. So it will be something like this. So option, which one is correct? Option C is basically correct. Now we have positive charge and negative charge. So we have this positive charge and we have this negative charge. Okay. Come on. Can you just show me? Okay. That's nice. Is YouTube enough to crack JEE? I don't know how many times I have answered the same question. See, if you say, is this enough? Is that enough? You have to go with basically different number of, like, you have to stick to one material only, but you have to follow a lot. Understand? You have to solo. If I, for example, say in this class or in a lecture, I can show you only like 10, 12, 20 number of problems. But if you really want to get a good rank in JEE, then you have to solo hundreds of problems. If you really want to be an IITian, you have to solo, next level number of problems. Understand? So that is, you have to basically use your brain, you have to use your efforts in order to crack that JEE. So nothing is enough. Okay, I can just show you the main problems. Rest, it completely depends upon you. Okay, so you study in Parepura or something like that, or somewhere else. So now I want you people to make the graph of this one. So this is basically positive charge and this is basically negative charge. Okay, fine. Now what happens in case of positive charge? Electric field is away. Electric field is positive. Understand? In case of negative charge, in case of here, it will be electric field will be negative. Now here, electric field will be positive. Over here, electric field, sorry, it will be negative. Electric field will be negative. Over here, electric field will be basically positive. Electric field will be positive. Understand? Yes. Now see, what we're gonna be doing exactly. In this case, if I say, for example, this is minus q placed over here. Electric field is negative. Electric field is negative from the right side. So it will be something like this. Understand? Electric field is positive from the left side. So it will be something like this only. Fine. Now let's move on to over here. Electric field is positive from the right side. So it will be something like this. So it will basically be like this. And electric field is negative from this side. So this is the, now I want you people to solve this one. This is basically plus q and a 9q, or you can definitely take this is plus q and minus 4q. Okay, okay. Here the conversation starts. The fight begins. Being artist, har koi teacher. It depends on student. To which teacher they connect well. Don't say bad about any teacher. Okay, that's nice. How much year experience do you have and have to join Unacademy Plus subscription? How much experience do I have? Why do you are you offering me any sort of job? That's why you're asking me my experience. Fine. Okay, how to join Unacademy Plus? You have to download the Unacademy app. Over there, you can go log in or sign up over there. Once you are done with the sign up, put your number, email address, name and all. Once you get done with that, afterwards you have to basically there will be present over there 3 lines. On that you have to click. There will be plus courses, free courses, iconic subscription. Definitely you should go for the iconic subscription, press it over there, or plus subscription, press it over there, and it shows how much you have to pay for that. And if you want the maximum possible discount, you can use this code YAWAR. So use my code only. Okay, if you are studying from me, then you are supposed to use my code only. Okay, I had got scholarship in Kai, but I didn't join. Okay, that's nice. Fine, fine, fine. Oh, Jagdeep, very sorry to hear that, bro. Yes. Yes. May God bless you. And may God bless your family as well. Fine. Okay, that's very nice. That's very nice. Come on, come on. It's not fight, sir. Then what was it? It's okay. Even if it was not a problem, Kushi. Okay. Azan time and I missed it. Okay. Fine. Now let's have a look on this one. If I say, for example, there is a plus Q over here. This is a plus Q over here. This is electric field. This is R. This is electric field, negative electric field. This will be negative electric field. This is negative of R. This is plus Q and this is minus of a 9Q over here. So what's going to happen? Electric field will be towards this one. Electric field will be towards this one. Electric field will be away from this one. Electric field will be away from this one. This is electric field. This is, let me just show you the options over here. If I say the option A will be something like this. Okay, you just try to have a look on this exactly. Okay. 1 second. 2 negative. Fine. Okay, so if I say it will be something like this, if I say it will be something like this, and D, if I say it will be something like this. Come on, tell me what is the correct option in these cases. Or none of these is correct. I have to check it first. Okay, so this will be basically electric field. Electric field will be, in this case, it will be negative. Electric field in this case will be positive. In this case, electric field will be basically, it is towards this one. Yeah, it will be positive. In this case, electric field will be what? It will be negative. Understand? Everybody understood this one? Everybody understood this one? Fine. B, sir, B. Come on, let's have a look on this one. What's gonna be the option number? So in this case, can I say that, see, this is 9Q, this is 9Q. From this side, electric field is negative. This is the right side, so it will be somewhere around here. Okay, from this side, electric field is positive. In the positive R, understand? This, in the negative R, electric field is positive. It is something like this. Okay, fine. And over here, electric field is basically positive. On the right side, it was basically easy. I thought of something else. Okay, fine. And over here, it will be something else. Yeah, option B is basically correct in this one. Let's move on to the next one. I was basically searching for this. Exactly, I was searching for this. Over here, I'll give you the same options. Over here, I'll give you this option. One second. I need to rub this exactly. And C option. Yeah. Arey, keep karna bhai. And option D, I am just mentioning it over here. And it is something like this. Come on, I want everybody of you to. Yes, it can't be symmetric. Come on, I want everybody. Why it can't be symmetric? This, okay? Which option is correct over here? Which option is correct over here? Everybody. Okay, which option is correct over here? I want everybody of you. Come on. Let's basically focus on this one. This is the electric field. This is the electric field. And this is basically this is minus E. I can say this is nothing but minus E from this side. This is minus R and this is definitely plus R. Can you guys solve it? Everybody of you. Okay. So if I say basically what it is, this is plus 3Q. So if I say plus 3Q, okay, and this will be over here, I'll show this plus 12Q over here. Okay. Now, can you guys tell me exactly? Can you guys tell me? See, this plus Q, electric field will be away from this charge, so it will be positive. Over here, electric field will be, I would say, negative. Now, in this case, electric field will be basically positive. Electric field, this is plus 12Q, exactly. So, electric field will be basically negative, exactly. Fine. Yeah, let's follow this one. So, this 12Q, understand, let's talk about this 3Q first. In this 3Q, this will be positive electric field on the right side. So I can definitely show it on the right side. This is the right side of this one in plus R. So electric field is basically positive. I can show it like this. Fine. Okay. Now electric field is negative from the left side. So I can show it like this. Now come over here. Electric field is positive from the right side. Electric field is basically positive from the left side. From the left side, electric field is positive, so I can show it definitely like this. And in the right side, electric field is basically negative. Electric field is basically negative. So I can show it like this. Okay, this will be the exact graph, and over here it will be something. It has to be something like this. Okay, fine. And over here, towards the 3Q, there will be the null point. Why is it like that? Because see, this is a plus 12Q charge. This will have more electric field intensity. So it is, you can understand it like this. This electric field will enter the region of this electric field. Understand? That's why it will have more region of this electric field as compared to the electric field of this plus 3Q. That's why I'm saying the graph will be something like this. It will not be the symmetric graph. It will be this one. It will be not this, not this. It will be definitely this one. Yeah, exactly. Fine. Now I want you people to solve this at your home. This is your homework and we are done with this one. Kitna time ho? It's 7:25. Okay. Come on. So, ladies and gentlemen, this is basically apart from this YouTube platform, we teach on Unacademy Plus. We teach on Unacademy's platform. For that, you have to basically download the Unacademy app. And in that Unacademy app, you will be getting this plus subscription. You can take this Iconic subscription. What are the benefits that you're going to get in this plus subscription? That is live classes, weekly tests, unlimited access, structured courses. Okay. So what is this unlimited access? It means you can watch anybody's lecture any damn time. Understand? That's nice. Okay. Anybody's lecture any damn time. And in this Iconic subscription, you will be getting all the benefits that you get in Plus, and extra you will be getting, that is personal guidance, test analysis, experts guidelines, study material, and study planners. This personal guidance is, you will be getting an mentor. Understand? You will be getting a personal mentor who will guide you throughout your exam, how to crack your JEE. He'll definitely take all of the confusions out of your mind. So anybody who is looking for Plus right now, I suggest him to take the Iconic subscription. Fine. Now, this is my username on Unacademy. You can definitely follow me over there. You can have a conversation with me as well. This is my username, YAWAR. Search it on Unacademy. You'll get it. Okay, fine. Now, this is the IIT JEE Iconic Subscription. If you take this subscription for 12 months, 18 months, or 24 months, you'll be definitely getting what? Branded notes that will be delivered to your doorstep. That too not in soft copy, that too in hard copy, okay? You don't have to learn from the PDFs anymore. Now, this plus subscription offer is basically, if you take it for 12 months, you'll be getting 2 months of extension. If you take it for 24 months, you'll be getting 2 months of extension. And this plus subscription, if you take it for 12 months, you have to pay this much of amount. Now, if you want the maximum possible discount from this amount also, you can get it by using this code. For 18 months, you can take it, you can get it for this one. And by using this, you can definitely get the maximum possible discount. By using this, you can get the maximum possible discount. This is the code. This is basically the price for 24 months. Similarly, you can take this Iconic subscription for 12 months. You can take it for 18 months. You can take it for 24 months. By using this code, you can definitely get the maximum possible discount. By using this code, you can get the maximum possible discount. It's over here. Whenever you want to come. Okay, right now busy with some stuff. I'll tell you when exactly. Don't worry about that. And this is the IIT JEE Combat, Mega Combat. That is, if you basically enroll for this scholarship test, if you give this test, you will be definitely getting a scholarship that is more than 4 crore rupees, understand? So you should definitely grab this offer. And if you get the rank from 1 to 3, you'll be getting 1 year of IIT JEE subscription completely for free. Okay, fine. Love you too, bro. So this will be on 22 of August at 11 a.m., 60 minutes, 21 questions. And some of the benefits you're going to get from the Amazon ad as well. Go for this one. This same Mega Combat, win something big. Fine. Now, so if you find any of my content as inappropriate, you can definitely report. The link is in the description below. And before leaving, you need to basically like this video and subscribe this channel. Thank you so much. It was nice interacting with you people. Subscribe to this channel, hit the bell notification, and like this video, share this video. That's all I can say. Okay, tomorrow we have class for class 11th. Okay. Thank you so much. See you guys very soon. Till then, bye-bye. Take care. Boy, tata, sir. Thank you.